Last time you were introduced to the concept of subsetting a character vector. More specifically, you learned to use the first of the three different ways of subsetting character vectors, namely using indexing. And for that, I used numbers within the square brackets operator. Let's turn our attention now to another way of subsetting a vector by using relational or logical operators. This method allows to retrieve data that fulfill one or more conditions, and therefore it is a very useful tool for powerful explorations in the data that reveal underlying characteristics of the dataset. However, this powerful technique for exploring vectors and other more complicated R objects, as you'll see in the near future, comes with a cost. Namely, you need to understand how the underlying logic of using it works. And to that end, I will spend some time in the following videos to help you grasp the gist of it. So, in this video you will see how relational operators in R function, and as a necessary intermediate step on your path of understanding and using them, you get to know the Boolean values, a new type of data that is returned when you use these operators. No worries, I will take one concept at a time. The first step is to learn how to express yourself in R when asking whether two or more values are the same or differ, and in general how to use relational operators, as we call them, for doing that. So, lay back and in a couple of minutes you will have understood how you use them in combination with the square brackets for retrieving sets of values out of a character vector. So let's dive in. The first operator is the equality operator, signified by the double equal sign. With the equal operator, you can compare two values for equality. For instance, the following line is about to compare the two strings on the left and on the right of the equality operator. Notice that since I typed these two strings, although their content is the same, namely it consists of a number of specific symbols that happen to be the same and in the same order, they will still be interpreted by R as two strings and not one. What we ask it to check is whether these two strings indeed consist of the same symbols and in that exact same order. Now, as it usually happens, when you ask something from R, it will return you a value. In our case, when you will be asking it to check for equality between these two strings, it will always be returning you one of the two values, true or false. True if indeed the two values under comparison are the same in the way I just mentioned, and false otherwise. Let's go directly to the example. The two strings here are the same and therefore, as expected, the return value is true. In this second line, I get false, because apparently the two strings do not consist of the same characters. Of course, you can use the equality operator if you want to check whether two numeric values are the same, as here. Appreciate that the values true and false are not strings of 4 and 5 separate characters. They have their own status as values, and together these specific two values comprise their own data class or type. You can think of these two values as being the only two animals of one species. Being a type of data, as the character symbols in R are called strings, this type of data also has its own name and is called the Boolean type of value. So, the values true and false are the two Boolean values. Let's move on to the second operator, the opposite relational operator, namely that of inequality. This one checks whether the two objects are not the same. If they are not the same, then the true value is returned. If they are the same though, then false is returned. So, in the evaluation of the following two lines, we expect the exact opposite values, namely in the first one the value true, since the inequality of the two strings is indeed true, and the other way around for the second line of code. Now, these operators can be used for comparing more than two values. For instance, you can use the equality and inequality operators for comparing two character vectors pairwise. Let's see an example of how this works. I created two different vectors here and assigned them to the variables name _1 and name _2. If I use the equality operator, the two vectors are compared using their indices, namely the positions of the strings within each vector. The first string in names _1 will be compared with the first string in names _2. The strings in the second position of both vectors will also be compared for equality, and so on and so forth. The result is now a vector of Boolean values, where the index of the vector, of this return vector, maps to the Boolean values of each comparison. Namely, the first member of the vector, false, is the result of comparing for equality the string Alexandros from names_1 and Nick for names_2. The second value, true, is for comparing the strings in the second position of the two vectors as I just mentioned, namely the two identical ones, Georgia, in terms of their content. Moreover, you can compare a character string with a whole vector of strings. The comparisons are done pairwise again, but this time the one side of the comparison always includes the string. In this line of code, what's compared is the string Alexandros with each member of names_2. The third member of names_2, as you see, is equal to Alexandros, and that is why the third member of the returned vector is true. The last case we're going to see is when the two sides of comparison are vectors with different sizes and the pairwise comparisons are not done in a one-to-one correspondence. Some members of the bigger vector are not compared with new members of the other side. However, the pairwise comparisons are done, but this time the comparison starts all over for the smaller vector. Let's see this example. I renamed the vectors name_1 and names_2 into names_3 and names_4 correspondingly, and made one more small change. Namely, I deleted the last two members of names_1, Zahir and Ibrahim. When the pairwise equality comparisons are done, the pre-last comparison for Zahir is done with the first member of names_3, namely with Alexandros, since there are no new members in names_3, and that is why it starts all over for names_3. For Jim of names_4, the comparison is done with the second member of names_3, Georgia. So, this might not be a desirable feature if you compare your language data, since you care whether the vectors you want to compare have the same size, and there are other ways for remedying this shortcoming of the relational operators, as you will learn later. Now, the last and crucial thing to note is that internally R stores Boolean values as two numbers, 0 and 1. 0 corresponds to the false Boolean value and 1 to true. What this means is that when you see the value true, you would rather think of it as the number 1 and the number 0 for the value false. Let's see why this would be useful for you. Since the vector of Boolean values returned from the comparisons of names_1 and names_2 are internally represented as a vector of 1s and 0s, you could sum all these 0s and 1s of that vector, and you will find the number of pairwise comparisons done with the equality operator for names_1 and names_2 that have identical strings. Since false values are simply translated to 0s, when you would create the sum of all these internally represented numbers of the returned vector of Boolean values, they would not contribute anything to the sum of these internal numerical values. Let's go ahead and find the sum of the internal numbers that represent internally the Boolean values. You can use the sum function that takes all the numerical values of a vector and gives its sum. In our case, it recognizes that the Boolean values are translated as numbers, and so it proceeds and takes their sum. That is why it outputs a number 4, which means that the two vectors have identical strings and in 4 different positions. As you can see, I use nested code, whereby the relational statement is placed within the sum function, which means that the function sum will take as its input the vector of Boolean values. Let's try to check the number of times a specific string that we are interested in is identified with any of the strings of names_1. Recall that this is the case of comparing pairwise a single string with each member of a character vector. Here, the sum function outputs 1, and that means that there is only one successful pairwise comparison for equality. Let's try the same for the inequality operator. As you can see, by placing the inequality operator in the same place, I get 3. The number of the rest of the pairwise comparisons when the two members of the two vectors are not equal. Recall that the size of the two vectors is 7. Let's check now the inequality comparison between a string and a vector. As expected again, the number is 6. That's it for now. Make sure to freeze the video on this slide with the code summary, and then if you enjoy this video, feel free to give it a thumbs up, and don't forget to also subscribe to the channel by pressing the relevant button on the video or on channel's homepage. And then, in order to get updates when new videos are released, you need to activate the bell notification that's sent on channel's homepage.